Okay, so starting off with number 1, all we're doing is we're just entering values in. We're not using summation formula. We're just entering in using our calculator to find the total of those values. Okay. Okay, so 1 gets inserted in for I first. Next up, 2. And then finally, the last value we plug in for I is 3 because 3 is the upper bound. 3 goes in for here, so 3 times 2 is 6. We have the cube that's really pushing the values out to be really large. Okay, questions 1. Okay, number 2, use sigma notation to write the sum. Now on the quiz, you'll get to start at I equals 1. For this one though, I think the hint is that you're going to start at I equals 3. So let's say this was I equals 3, then this must be I equals 4. Okay, sigma notation. We know we're going to go from 3 to 6. Okay, now the next step is fill out all the parts that are unchanging because those are going to appear every time a value is produced. So the 7 is going to stay, the square root stays, the division line stays. So just to figure out what goes inside the square root, as well as what happens with the denominator. So square root is pretty straightforward, right? What goes inside the square root? Just I, right? Because it's just incrementing by 1, and it's just going to go start it with 3. What about the denominator? Yeah, so 3 cubed, 4 cubed, 5 cubed, 6 cubed. Okay, and we're on page 15 of your packet. Let me know if you're missing this worksheet. Okay, number 3. Use 4 middle rectangles to approximate the area of the region. So 4 middle rectangles, we have to go through width formula, right? You got we're build our width from scratch here. Okay. A is 1, B is 7, N is 4. Yes.
Is N
Number of number of subintervals, which in this case is rectangles, and so it's 4. Mm-hmm. Okay, everybody good with width? Okay, so now that we have our width, we're going to build our subinterval. We're going to start at 1 because 1 is the left endpoint. And we're going to keep adding 3/2 until we reach our final destination, our right endpoint of 7. So 2/2 plus 3/2 is 5/2. Plus 3/2 is 8/2, or 4. Plus 3/2 is 11/2. And plus 3/2 is 14/2, which is 7. Okay, but we can't stop here, right? It's asking for 4 middle rectangles, so we have to find the midpoint of each of the subintervals here. So the way we find midpoint is we just find the average of the 2 endpoints of each subinterval, right? So the way you find average is you add the 2 numbers and you divide by 2, or add 2 numbers, multiply by 1/2. That's the easier way to go. So 2/2 plus 5/2 is 7/2. Half of 7/2 be 7/4. Average of these 2 numbers here, 13/2 times 1/2 will be 13/4. Eight over 2 plus 11/2 is 19/2. Half of 19/2 is 19/4. And then 25/2, half of that is 25/4. Worksheet is from the packet, but maybe missing that. You have one?
Thank you.
Okay, so the reason that we found these midpoint x values is because these are the values that we're going to attach to the graph. These are going to be the points that we enter into the function to get the specific heights. Okay. Okay, rectangles here, width times height. Every width of our, we've predetermined, we found our width. Every width is going to be the same, 3/2. But the height for the first rectangle is going to come from 7/4, so we're going to do f of 7/4. And we go down the line, width times height for every rectangle. So to find the heights, we enter 7/4 into the function. 3 times 2x squared, or 3 plus 2x squared. $9.125. All right, everybody okay with how we insert these x values into the function? We go down the line. Next value to insert into the function is 13/4. And we just repeat that process for all the other fractional values we have to insert in. Okay, so now it's just making the calculator do all the work for us here. All right, everybody go okay so far, 1 through 3? Okay, use table of values to estimate the below. Use 3 middle rectangles. We make sure that you are starting your bracket at the starting point where the interval is located. Don't always assume that we're starting at 1. Right, if you look at B, we're starting at 5, so we want to make sure that we're paying attention to our starting and ending point so that we're not accidentally building our brackets in the wrong places. Okay, so 1 to 15, we have to create our subintervals. Make sure that every bracket covers the same number of ordered pairs. So 1 to 15, 3 middle rectangles. So this will be 1 here, 2, and 3. Okay. The width is going to come from the x value, but there's a very specific way that we find the width. We subtract the endpoints of the subinterval to get that width. Make sure you're not adding, right? We're finding that distance from 1 to 6, so 6 minus 1 is 5. Okay, nothing to do with the middle number. The middle x value is not going to play a role at all. Okay, so 6 minus 1 is 5. And then within each subinterval, we want to pick out the correct height. It says 3 middle rectangles. So you're either choosing between 4 being the left, 7 being the right height, or 2 being the middle height. So you got to pick 2. So 5 times 2 is going to be the area of the first rectangle. Any questions there? Okay, second rectangle. 11 minus 6, that's a distance of 5, that's your width. And then the height comes from that y value there. So 5 times 3. And then finally, 11 minus 5 is 4, 4 times 6. (10 plus 15 plus 24, 49). Okay, questions there for part A? All right, part B. We have a new set of subintervals here. from 5 to 11. So I have to space this out so that, draw it out so that every subinterval sees the same number of ordered pairs. Start in the middle of your ordered pair, then extend to the middle of your end ordered pair. That's one subinterval. Pick up your next subinterval at the same point as your previous subinterval. So you're always going to be sharing an ordered pair each time you build your next subinterval. 6 to 8, and then 8 to 11. Okay. Width times height, 6 minus 1, that's distance of 1. 8 minus 6, that's a width of 2. 11 minus 8, that's a width of 3. And then the height is going to come from the second row. We want to choose right-handed rectangles, so we want to choose the right endpoint of every subinterval. 7 is the right endpoint of the first subinterval, so 1 times 7 is the area of the first rectangle. Second rectangle, 2 is the width, 3 is the height. Third rectangle, 3 is the width, and 1 is the height. Okay, good so far. All right, next up, trapezoid. Trapezoid area, make sure you memorize your trapezoid area formula. It's width over 2, height 1 plus height 2. Okay, 4 trapezoids from 6 to 15. Now, we're not going to see it in this example, but the most common mistake that I see with people with trapezoid approximation is if your interval spans across multiple ordered pairs. I see students who want to add up all the heights, but every trapezoid, you're only picking 2 heights, right? So if there are any middle heights that show up, you're going to ignore it. You're just going to use the ones where the bracket starts and ends. Okay, so remember, every trapezoid is only going to take 2 heights, even if you see a bunch below. I know we're not going to see it here because every subinterval only has 2 heights, so that just feels that you're not going to make a mistake here. But if it spanned across multiple ordered pairs, make sure that you're still only picking out 2 heights for each trapezoid. Okay. 8 minus 6 is 2. Okay, so I'm going to write out all the width. All right, so width over 2, that's 2 over 2. Height 1 plus height 2. Remember, you're always pulling your height from your second row. So that's 7 plus 3. Okay. Second trapezoid, width of 3. And then 3 plus 1. And 2 over 2. 1 plus 6. And then 2 over 2, 6 plus 5. Okay, calculator gives you 34. Again, remind you, if you ever see table of values, that you're never using the width formula, right? This is not where you use the width formula. And you use it for approximation with no width information given. You got to build that width on your own. And also you're going to use it for a limit definition, but not if the table of values are given to you. Okay. All right, number 5. Area definition. Let me write that out. I'm going to call this f of x. Oops. Okay, area formula will be provided for you on the quiz. All right, so first things first, let's fill out all of our a and b values. A is -1 and b is 1. All right, so my width is all right, so piece by piece, we're just going to build our area formula. All right, everybody okay so far? Right, we're just rewriting the formula and we're just inserting -1 and 1 wherever a and b shows up. Okay. We're leaving n alone because we eventually want to push n out to infinity. We don't want n just to be an approximation. Okay. We want there to be enough rectangles that will produce an exact area. So now we have to involve the original function so that we can get this out of function notation. Okay. Wherever I see an x, I'm going to leave an empty space because I want to reserve a spot for my argument value. So -1 plus 2 over ni will go in that space. All right, first things first, we're going to FOIL this out, right? Take care of that binomial. But once I FOIL, I have to still leave that in a set of parentheses because I have to still distribute the -2. Once I do that, then I can handle that 3 and then finally the width. Okay, 3 minus 2 is just 1. All right. Distribute the 2 over n through. Okay, so now everything is cleaned up, all the parentheses resolved, all the like terms combined. Now we can involve the summation and then the summation formulas. As I do that, I'm also going to push out any coefficients that's not part of my summation, or separate the each parts of my summation formulas here. Oops, n is pushed up to infinity. All right, so took our time to separate each of the summation so that we can see exactly where the rules will get applied. I'll provide this formula sheet for you. Summation 1 is n, summation I is n times n plus 1 over 2, and summation I squared, n times n plus 1, 2n plus 1 all over 6. Okay, once you get to this messy last term, just pull the largest value. So 16 times n times 2n, that will give you 32n cubed. All the other terms will just be a lower degree. Just take the ratio of the coefficients here. So 2 over 1 plus 16 over 2 minus 32 over 6. Okay, questions? Okay, back page. The directions got cut off at the top, at the bottom here. Direction says find the general antiderivative of g of x. Okay. All right, so we learned that we have to clean up a lot of our terms before we can apply power rule, right? So make sure that we fold this out, take the time to expand. Make sure we're expanding this correctly, right? We're not distributing the 2 through, we're not distributing the exponent through, we're foiling this out. Once I FOIL out 2x minus 1 squared, which becomes 4x squared minus 4x plus 1, I'm still not forgetting to distribute the x through, so that's my next step. Once I distribute the x through, then I should be ready for each term to apply power rule. Every term is set up nicely now. Apply power rule. Add 1 to the exponent divided by the new exponent. And then general antiderivative, we're always going to have a plus c. Okay, number 7, asking you to find the antiderivative. But a couple of steps have to be done before we apply our integral, right? We have to convert radicals to rational exponents. We have to push all the denominator variables to the top, and then we can apply power rule. Okay, so I'm going to do two things at once. This becomes x to the 1/3, and I'm also going to push that x to the 1/3 to the numerator. Square root of x, the same thing as x to the 1/2. Now, when you move this x to the 4th up to the top, the 3 is going to stay in the denominator. Okay, so I'm not going to move the 3, I'm just going to move the x. So now we're ready for power rule. Add 1 to the exponent divided by that new exponent. Okay, any questions about power rule for each of these terms that we applied? Okay, so cleanup, push all the fractional denominators to the top by flipping them. Now, one more step to clean up here. This is 12/2, which is 6. And finally, if you see any negative exponents, push it back down to the denominator. Okay, questions so far? Number 8, find the antiderivative. I'm going to go ahead and separate each into individual fractions. I did it a different way on the key. I pulled that denominator up first, but I think it's easy to make a mistake if you don't have a parentheses set in that numerator. So I find it to be safer to ask you guys to separate them into individual fractions. That way, you're not forgetting that every numerator is being affected by that square root of x. As I'm doing that, I'm also converting them to rational exponents. Okay. 3 minus 1/2, the same thing as 6/2 minus 1/2, which is 5/2. Remember, as you do this, you haven't done any calculus yet. You're just getting these terms ready for power rule. And 1/2 minus 1/2 is 0, which is 1. So basically another way to think about this is that you're matching variables, which just cancel out. Okay, 1/4 minus 1/2, the same thing as 2/4, or sorry, 1/4 minus 2/4, which is negative 1/4. All right, any questions with how we cleaned up every term to get them ready for power rule? Okay, so now we can apply power rule. We add 1 to the exponent. What happens to the 2? 2x, yep. Every value gets, degree gets increased by 1. Constant becomes a linear. Okay, I'm going to flip those denominators to the top. Okay, number 9, find a general expression starting with f double prime. So take the antiderivative twice, and each time you find the antiderivative, a plus c will show up. The nice thing is that every term is set up and ready for power rule. There's no need for us to do any cleanup. We can jump directly into power rule. Okay. Setting up my notation so that my next antiderivative process will bring me up from f prime to f of x. Okay, what does this c become? Cx. And then this will produce its own constant. So you can either say plus k or plus c sub 2. And then just do a little bit more cleanup if you can. All right, so now I'll find the specific expression. Each time we go through the antiderivative, a plus c shows up, and then we're going to try to resolve that c with a numeric constant. Same process. Okay. We do have an order pair at the F prime level. We can go ahead and insert right, so 9 gets inserted for F prime, -1 gets inserted for X, and then we're just trying to solve for C at this level. -4 plus 4 is 0, 9 minus 9 is 0, so C ends up being 0, which tells us that it's really not going to, there's not much for it to keep track of. Okay, moving on. One more antiderivative to apply. Power rule again. Okay, my second C value shows up. I can find my C value using my order pair at the f of x level. That's where I am now. 3 goes in for y, 1 goes in for x. All right, so once you find your C value, don't just stop there. Go back and rewrite your function, and then go ahead and replace that C value that you found into your function. That way you can graduate that general expression into a specific one. All right, any questions? All right, thank you.